Hi, I'm Mr. Pei. Are you looking for more information regarding KSSM Physics Paper 3? This video will be the right video for you to referring to. In this video, I'm going to discuss with you another example of question in Paper 3 regarding the experiment 3.5 to determine the electromotive force E.M.F and the internal resistance of the dry cell. As mentioned in my previous video, there are two types of questions in Physics Paper 3. There are the first one, guided practical assignment, which is known as Tugasan Amali berpandu in BN. This type of question will be seen at question number 1 or number 2. In this type of question, the procedure and the diagram of the experiment will be provided. For the second type of question, there is non-guided practical assignment, and in BM we know as Tugasan Amali tidak berpandu, and you will see this type of question at question number 3. For this type of question, the procedure and diagram of experiment is not provided. So the candidate has to plan the experiment according to the apparatus and the material provided. Today I'm going to discuss with you the example in paper 3 in the type of question which is guided practical assignment. This is a compulsory experiment you have already did at your chapter 3 Form 5 syllabus electricity. The experiment is experiment 2.5 to determine the E.M.F and the internal resistance of the dry cell. So basically the arrangement of the apparatus will be like figure 3.26, and the manipulated variable you have to factor in this experiment will be the reading of ammeter, and as mentioned in my previous video, so we need at least 5 reading of manipulated variable for plotting of the graph. So the manipulated variable here will be the reading of ammeter, and the responding variable for our measurement here will be the reading of voltmeter. So after we get the 5 data of our MV and RV, we have to plot our graph V against I in this experiment which you have already did. So and then we have to relate the graph to the equation. So the equation is the voltage drop, which is the IR equal to E minus V. So according to the graph which is V against the I, so we have to rearrange the formula to become the format of Y equal to MS plus C. So that we have to move our V to our left side and move our IR to our right side. So the equation will become V equal to minus IR plus E. So basically you'll get the graph like this, like figure 3.28. So you'll get the gradients which is decreasing. So the equation here mentioned that the gradients will be representing the value of our internal resistance, and the intercept Y will be representing our electromotive force. So in this video, I will try to relate this experiment 3.5 to the question in paper 3. So let us see the question together. Now let's read the question together. So this is the checklist for the apparatus and material provided. So there are 7 apparatus or material for this experiment. There is a 1.5 volt dry cell, cell holder, ammeter, voltmeter, rheostat, switch, and 6 30 cm long connecting wire with crocodile clip. So if you check all the material apparatus is functioning, and with the correct quantity, you may take the checklist. Okay, so you have 5 minutes, okay, to check and plan, okay, your experiment. So after you check your apparatus and material, immediately you go to the next step. You have to read, okay, your question. Okay, as mentioned, our example in paper 3, okay, is regarding the guided practical assignment. So the procedure and diagram is provided. Okay, so this is the end of the experiment. Let us read together, okay, the question. Okay, so you are required to carry out an experiment to determine the electromotive force, E.M.F, and the internal resistance R of the dry cell. Okay, so the step 1, you have to identify the MV, manipulated variable, and responding variable of the experiment. Okay, so however, the M is not stated clearly, the MV and RV for this experiment. Okay, so but don't worry, you can get it at the procedure. Okay, so the first, arrange apparatus as shown in the diagram. Okay, so this is a diagram. Second, the switch is closed. Okay, so the switch here you have to close, and the rheostat is adjusted. Okay, so we have to adjust our rheostat. Okay, so that we get our first reading of ammeter with 0.2 ampere. Okay, so from here we are clear that this is our first MV. Okay, so the third procedure, the voltmeter reading is recorded as potential difference. Okay, so this will be our first responding. Okay, so here you can see the ammeter is connecting in series. Okay, so we have to get 5 manipulated variable by reading the reading of ammeter and the 5 responding variable with the reading of voltmeter. Okay, so the step 4, the experiment is treated with I equal to 0.3, 0.4, 0.5, and 0.6 ampere. Okay, so that means, okay, so we have to know, okay, how to get our data. Okay, so we have to relate the diagram to MV and RV. Okay, so as mentioned, okay, so we will get our 5 manipulated variable, okay, by reading the reading of ammeter and the 5 reading of the responding variable with your reading of voltmeter. Okay, okay, so the question here, okay, asks you to plot the graph P against I. Okay, so which is actually same as the experiment, okay, you did in your experiment 2.5. Okay, so that you must very clear. Okay, so this question, the graph will be have a decline of the gradients. Okay, so this question will be easier compared to my previous example, which is modification of the experiment 2.5. Okay, so the last step, you have to draft a table everywhere. Okay, so you can draft here. Okay, so the current you have to measure is 0.2, 0.3, 0.4, 0.5, and 0.6, and you have to take your responding variable for each reading here. Okay, okay, so after you very clear what reading, okay, you have to take. Okay, so you may start your experiment. Okay, so remember that, okay, my advice that your time, okay, management is very important. Okay, so maximum I advise 20 minutes, okay, to finish your experiment. Okay, because the marker will only see your answer sheet, okay, but not see how you conduct your experiment. Okay, so before our discussion, okay, so let us see how Mr. Fair conducting this experiment. In this video, I am going to show you the stimulation of experiment 2.5 to determine the electromotive force, E.M.F, and internal resistance of a dry cell. Basically, most of the connection will be starting at the dry cell holder. You may watch the simulation at my previous video clip, okay, which is started at the dry cell holder for the stimulation. However, in this video clip, I will show you the connection of the circuit actually can be started at any polar electrical devices such as an ammeter. So in this diagram, you can see that the series circuit involving 4 electrical devices, that is switch, dry cell holder, ammeter, and rheostat. So besides the dry cell holder, there are actually another two devices which have polar, that is voltmeter and ammeter. So because of the series involving majority of devices, so that the polar devices chooses as series circuits more suitable. So besides the dry cell holder, there are the best choice will be ammeter. Why we need to start the connection with the polar electrical devices? This because we want to avoid the mistake of the polar connection when we connecting the electrical devices. As mentioned, most of the connection of the experiment is starting at the dry cell holder, but actually the connection can be started at any polar electrical devices. At this experiment, I'm going to show you the starting of the connection at the ammeter. The material we are going to use in this experiment will be voltmeter, ammeter, rheostat, one dry cell, battery holder, and switch together with the 6 connecting wire with contact clip. That's all for the material for the experiment. Now, let us arrange the apparatus according to the diagram given in the question. Ammeter will be here, voltmeter will be here, and switch. Basically, this is the position of all electrical devices according to the diagram. As mentioned, we will starting our connection in this simulation with the ammeter. Connect the contact clip to the 1 ampere of the positive terminal. So read your reading at the 1 ampere scale of the ammeter. Another end, contact to the terminal C of the rheostat. The detail of the simulation of rheostat can be seen at the video which is at the right corner. Now connect the contact clip to the next terminal, which is the terminal B of the rheostat. Make sure the metal parts of the contact clip is connected to the metal parts of the button, and another end connect to the first button of the switch. Now we have to contact the button of the switch with the terminal positive of the dry cell holder. As we are using one dry cell, so connect the contact clip to the first node of the positive terminal, which is the first button of the red button of the dry cell holder. And next, connect the negative terminal of the dry cell holder with contact clip and the black color of the button. Another end, connect to the black button of the ammeter, which is the negative terminal of the ammeter. So you can see the series circuit is complete connection, and you can test the connection by close the switch, and you can see the deflection of the ammeter point, showing that the connection is successful. Now let us continue the connection with voltmeter, which is in the parallel circuit. We're starting the connection with the negative terminal of the contact clip, okay, to voltmeter, and another end of the contact clip have to touching the metal parts of the negative terminal contact clip. That is similar for the positive terminal of the voltmeter. So contact the another end of the contact clip on the connection to the positive terminal of contact clip. Make sure the contact clip metal parts is contact to each other. This is a close-up view to show you that how two contact clip connecting at the terminal positive and terminal negative at the battery holder. So firstly, make sure that the metal parts of the contact clip connecting to the another contact clip at the battery holder. This is similar also at the terminal negative. The two contact clip of the metal parts contact to each other. So you can see the deflection of voltmeter. The switch open, showing that the reading of voltmeter is a E.M.F for the dry cell. When we close the switch, you can see the deflection of the voltmeter is reduced. This is because the current is flowing to the closed circuit, which is the series circuit here. how many decimal place should be taken for your manipulated variable and responding variable? So this is a quite common question asked by most of the students. So this is actually related to the sensitivity of the apparatus. So for the experiment, our manipulated variable will be current and measured by ammeter. So look at the ammeter. There are two red buttons here, which is the terminal positive for ammeter. So there are two scale you can measure by this ammeter, which is 1 ampere and 5 ampere. So which scale we should use when we are measuring the ammeter? Okay, so we must follow the scale listed in the checklist. What I mean by this? So before we start our experiment, the checklist will be list out what type of ammeter and the scale you will be able to use in the experiment. Okay, so in this question, the checklist already mentioned that the ammeter with 1 ampere scale we are going to use. Okay, so that means you are not able to choose the scale with the reading of 5 ampere. Okay, so that means the reading which is above 1.0 is not accepted. Okay, so I magnified the reading of the ammeter. Okay, so you can see that the smaller scale for the 1 ampere scale will be here. Okay, so from 0.6 to 0.8 there is 0.2 different. Okay, so between the 0.2 ampere here we have 10 small division, so divided by 2, so we get our smallest division here will be equal to 0.02 ampere. Okay, so you can see this is a calculation which I explained just now. 0.2 divided by 10, so you get the smallest division for the ammeter. Okay, with 1 ampere scale is 0.02 ampere. Okay, however you can see, so the pointer so it's at the middle between two smaller scale here. Okay, so what is the further smallest reading we're able to measure by using this ammeter? Okay, so it's circle with red circle. Okay, so you can see when the pointer is between the smallest scale, the smallest reading is equal to 0.02 divided by 2, so that means it's 0.01 ampere. Okay, so the reading for this pointer we can read up to 2 decimal place, and the reading will be 0.31 ampere. Okay, so we can conclude that with this ammeter, the decimal place for the ammeter should be 2 decimal place. Okay, however in this question is considered as a guided practical assignment. And the reading of the manipulated variable is already given, which is 0.2, 0.3, 0.4, 0.5 and 0.6. So since this is provided, so we can just follow the decimal place listed in the procedure. However, if the question asks at the question number 3, which is the non-guided practical assignment, so the procedure will be not provided. So you have to plan your experiment your own. So the decimal place for ammeter should be 2 decimal place. So next will be the discussion regarding the responding variable. So in this experiment 3.5, the responding variable here we have to measure the voltage potential difference by using the voltmeter. So you can look at the figure. Again, we have 2 different scale, which is 5 volt and 15 volt. So the checklist already given us the instruction we have to using the 5 volt scale, so that means we have to follow the checklist. So again, so I magnified the reading part. So you can see with the 5 volt scale we have to read the bottom part. So here you can see 0 to 1 we have 10 division. So 1 divided by 10 we get the smallest division will be 0.1 volt. Okay, if the pointer okay also point between the two smallest scale, okay, you can look at the red arrow, okay, which is circled with red. Okay, so that means the smallest reading will become 0.1 divided by 2, so we can read up to 0.05. okay, however the second decimal place will only 0.05 or 0.00. so in this case, okay, so we will get the reading for this pointer as 3.25. okay, 3.25 volt. okay, so that means the decimal place for the voltmeter will be 2 also. okay, but the second decimal place is only 0.05 or 0.00. so that means we accept your answer, which is 3.20, 3.25 and others. okay, we not accept the second decimal place which is not 0 or 5. that means like 3.24 will not be accepted. okay, so again we must follow the skill listed in checklist. For our this experiment we can only use the 5 volt. okay, so I hope that the discussion regarding how many decimal place you should taken with the example you can able to understand. So now we have to take 5 reading of our MV and RV. First we adjust the rheostat so that our first reading 0.2 ampere for the emitter reading will be get, and we get our first RV which is 1.15 volt at the voltmeter. Next we taken the second MV reading which is 0.3 ampere and we get our RV is 1.10 volt. Next we adjust our sliding constant again so that we get our third manipulated reading which is equal to 0.4 ampere. So that is 0.4 here. okay, and we get our RV is 1.00 volt. The next adjust again the sliding contact to 0.5 ampere for our emitter reading, so we get our RV reading 0.95 volt at the voltmeter. The last reading we need to get 0.6 ampere according to the procedure given by the question. So the reading is 0.6 ampere and we get the RV is 0.90 volt. So that is all data we have to collect. We have to collect at least 5 reading of our MV and RV so that we can plot our graph and tabulate our table. That's all for my simulation. Thank you. Okay, so students, okay, we have already finished conducting our experiment. We have already get our 5 manipulated rebel and also 5 responding rebel. Okay, so now the first question is regarding the tabulation. Okay, so the experiment above, for the experiment above, tabulate your data for V and I in the space below. Okay, so here is only 3 marks. Okay, so this is a table, okay, for recording your MV and RV. So normally MV will be at the first column, okay, and the responding will be at the second column. So here you have 3 important tips, okay, to get full marks, okay, in this question. Okay, so first you have to write the symbol, okay, and parameter for both column. Okay, and next, okay, you have to give the correct unit, okay, for both column also. So here ampere will be given for current, and the V voltage, okay, will be the unit for potential difference. Okay, so the next step, okay, you must make sure that you give the consistent decimal point. Okay, so for example here you can see the current, okay, reading which will be always with 1 decimal point. Okay, so 0.2. Okay, so the reading of the ammeter must be also, okay, follow the sensitivity of the ammeter, okay, which is here 1 decimal place. Okay, so for the voltmeter, you can see, okay, there is 2 decimal place, okay, for all the reading. So if let's say, okay, the reading of 1.10 you write as 1.1, which is only have 1 decimal place, and the 1.00 you write as 1, which is no any decimal place. So that means the answer for the potential difference is not consistent in the decimal point. So that means to get full mark, okay, all the value, okay, in the same column must be have same decimal place according to the sensitivity of the apparatus. Okay. Okay, so for the next question, okay, will be regarding the graph. Okay, so let us read the question together. Okay, so on the graph paper given, okay, so draw a graph V against I, 3 marks. Okay, so for graph, okay, you have basically 6 important tips, okay, to remember, okay, when you drawing your graph. Okay, so the graph here will be exactly same as the experiment you have already did, okay, in your experiment 2.5. Okay, so this is the reading, okay, I take from the previous table. So the first tips here will be you have to mention the symbol at the y-axis and x-axis. So here the question asks you to plot y actually V against I. So the y-axis will be potential difference and the current will be at the x-axis. Okay, so the second, you have to mention the unit for both axes. So the third, you have to give the correct scale for both axis x and y. Okay, so for this, firstly you have to identify the minimum value and maximum value for each parameter. For example, here the current minimum value will be 0.2, okay, and the maximum will be 0.6. So your scale must be cover minimum and maximum value. And the second, all the reading must be start with 0. Okay, will be origin here. And the scale also must be give with the multiplication of 1, 2, 5, and 10. Okay, so that means the 1 unit here, for example, at the axis x, okay, so the 1 unit representing 0.1. Okay, so for the y-axis, 1 unit representing 0.2. So it's considered as the multiplication of 2 for the y-axis and multiplication of 1 for the x-axis here. Okay, so your reading started with 0.2, but you cannot give your scale with started with 0.2 and then 0.3, 0.4, 0.5 or 0.6 like this. Okay, because the first 10 column is equal to 1 to 0.2 and consequently will be 1 to 0.1. So this one is considered as not consistent scale. Okay, so the mark will be deducted. Okay, if you given the scale is not in consistency. Okay, so the y-axis also cover the minimum value, which is 0.9, and the maximum value here is 1.15. Okay, so this is the third tips, okay, for plotting the graph. Okay, so the fourth tips here, okay, so you must give the size of the graph, okay, at least 4 times 5 unit, okay, or 8 cm times 10 cm, because we know that 1 unit here representing 2 cm, so that means the minimum size of the graph must be 4 unit at the x-axis and 5 unit at the y-axis. Okay, so this is the minimum size, okay, for the axis. Sorry, for the graph. Okay, so that means it's minimum half page of your graph paper lah. Okay, so the fifth tips here is you have to plot all the points correctly. Okay, so for doing this, you have to know the smallest division for each axis. So here you can see the first unit here is 0.1. Okay, so divided by 10, so that means the smallest box here representing 0.01 for x-axis. For the y-axis, it will be 0.2 divided by 10, so that means the smallest box here representing 0.02. Okay, Okay, so from here, the first reading here is 0.2, will be here, and 1.15. Okay, will be here will be 1.1. 1.15 will be between 1.2 and 1.1. Okay, so will be at here. The second reading 0.3 and 1.1, so will be here. Okay, so the others point will be the same. Okay, dot at here. So the 6 tips here, you have to draw the baseline. Okay, so what is baseline? So you can see at the line, upper part of the line we have a point, and the lower part of the line we also have our point. So both upper and lower part of the line also have a point, and the distance for upper part point, okay, to line, and the lower point to the line is same. Okay, so this is considered as a baseline. Okay, so if you fulfill the 6 tips, okay, I mentioned here, okay, you will get full marks, okay, for your graph. Okay, so next is a data analysis question. Okay, so let's read the question together. By using the formula E equal to V plus IR, okay, so this is the equation, okay, you have already learned in your experiment 2.5. Okay, so on the graph, determine the electromotive force on the dry cell. Okay, so from here, how we can get our E.M.F. Okay, so we will get, okay, by observing our graph. Okay, okay, so basically, okay, so the E is represented as the E.M.F. of the dry cell. Okay, and the capital R representing the external resistance. I is representing as the electric current, okay, here, and the small letters R is representing internal resistance. Okay, so here we have to rearrange the formula in form of Y equal to ms plus C. So we plot our graph with y-axis V, x-axis I. So from here, the E, which is the E.M.F, okay, is representing as the intercept Y. Okay, so intercept Y will be here. Okay, so this is the value for the intercept Y. So from here, you can zoom in and see, okay, here is about the 0.06, okay, so here the E.M.F, okay, will be 1.26, okay, so 1.2 plus 0.06, okay, so we get 1.26 volts. Okay, so the reading here, okay, so actually we have to get 1.5 volt if our battery is strong or new. Okay, so my reading here is quite low. Okay, this may be because the dry cell I'm using here is already low power. Okay, so you have to have your own data for this answer here. Okay, so the next, okay, so on your graph, determine the internal resistance of the dry cell. So how we get the internal resistance? Okay, again, so we arrange a formula. Okay, so here we very clear that, okay, so the internal resistance will be represented by the gradients. Okay, so from here you can see N equal to negative R. So R, which is the internal resistance, will be negative the value of the gradients. Okay, so gradients, how we can get full marks here, 3 marks. So first, you have to draw right angle triangle here, big enough. Okay, so this will be the first mark. Second, okay, we identify the point of the right angle triangle. Okay, so here we substitute the value. Okay, 0. Okay, so this value will be 0.6 and 0.9. Okay, so the gradients we get will be y1 minus y2 divide s1 minus s2. So the y1 here will be 0.9, y2 will be 1.26, and the s1 will be 0.6 minus 0. So we get negative 0.6. Okay, so as mentioned, internal resistance equal to negative of gradients. So we negative to negative 0.6, so the radians we get is 0.6, okay, ohm. So because this is a resistance. Okay, so you must give the correct unit for your answer to get full marks. Okay, so how we get V per ampere? So here you see the gradients for y-axis will be volt and the x-axis will be ampere. So we get volt per ampere. Okay, or actually equivalent to units of ohm. Okay. Okay, so for the next question, okay, is also data analyzing. So based on your graph, state the relationship between V and I. Okay. So again, we observe our graph. Okay. So here is the explanation of the interpretation of the graph, which you have already learned in your chapter 1, form 4. Okay, total we have 6 different shapes, okay, of the graph. Okay, so for this graph, okay, so you can see the line is decreased, okay, when the value x increasing. So, and this is a straight line. So this type of relationship, okay, we know as y decreases linearly with x. So here our y-axis will be v, our x-axis will be I. So we have to write as v decreases linearly with I. Okay, if you are interested, okay, to know more, okay, all the relationship, okay, in the interpretation of the graph, okay, you can referring to my video. Okay, so the link is you can able to click, okay, at the right corner. Okay. Okay, so we go to our next question. Okay, so it's also the data analyzing. Okay, so determine the value of R when I is equal to 0.35 ampere. Show on the graph how you determine the value of R. Okay, again we have to use our graph again. Okay, so the value of 0.35, okay, you have to interpolation. Okay, so 0.5 is here, and when we touch a line, okay, then the value will go to y-axis. So here the value will be, okay, so we can zoom in and we see, okay, this is the third box. Okay, so one smallest box for y-axis representing as 0.02. So here will be 0.06. Okay, so the answer, okay, here from the graph, okay, we can see when I equal to 0.35, after the interpolation, we get our V is equal to 1.06 V. Okay, so and then we use the formula, Ohm's law formula. Okay, so this is the Ohm's law. Okay, V over I, so we will get reading of resistance. Okay, so here the V equal to 1.06, okay, divided by 0.35, okay, you will get 3.03 ohms. So again, your answer must be have a correct unit. Okay, now we go to our last question. Okay, so it's the question regarding the precaution. Okay, so step 1 precaution that should be taken to improve the accuracy of the result of this experiment. Okay, so first, here the reference answer here, switch off the circuit immediately after the reading is taken to avoid overheating of wire. So that means you have to open your switch, okay, after you taking the reading. Okay, so to avoid overheating. The second precaution here, okay, you can write as ensure, okay, your eyes is exactly in front of, or write as perpendicular, okay, to the mirror of the ammeter and the voltmeter, okay, to avoid parallax error. Okay, so this is the discussion for precaution. Okay, so that's all for my discussion. Okay, in the another example, okay, of paper 3 in experiment 2.5, okay, which is a very close example to your experiment 2.5. Okay, so I hope that my discussion today will help you, okay, to understand more, okay, the knowledge, okay, how to answering the question in paper 3. Okay, so that's all for my discussion today. Okay, so bye bye.